There are few things that would be helpful for us to know, and that includes when r is equal to n, what does it mean? So in NCR, if r is equal to n, so it's basically NCN. That is selecting all the items. If we select all the items, how many ways are there? There's only one way, right? So basically the proof will look like this. We have seen this, but I'm still writing it: n factorial divided by n minus n factorial into n factorial. So this would be 0 factorial, that is 1. So this is 1 and this is 1. So this entire thing is equal to 1. Okay. So when we have r is equal to 0, that is we are selecting nothing. So how many ways are we looking at NC? 0, right? We are looking at r is equal to 0, right? So actually it should be something like this. That is showing that we are substituting this 2. We need to write it this way actually. Yeah, that would be better. So now, how is that we should be going about doing this? The proof will look like this. So n factorial divided by n minus 0 factorial into 1 by 0 factorial. So clearly this is 1, this is n factorial, so this and this will get cancelled. All of this leads to it being 1. Now fact number 3, or in this case fact number 1, those are note. NCR is same as NCN minus R. I'm sure you guys would have not noticed to that extent, but yes, it's a very simple thing. Say example, you have 15C10. We will get the same value as 15C5. Not the same selection of items, but the number of selection is the same. Okay, let me explain this with an example. So 5C2, that is we are selecting 2 items out of 5. That will be equal to 5C3, right? So in this case, let me show the entire steps of. So this is what it is. So basically this is 15C5. Similarly here, 3 is nothing but 5 minus 2, right? Does it make sense? So let me show it so that it's clear. Again, remember, selection of 2 items is not the same as 3, but the number of outcomes is same, is what they are trying to tell. So there are 1, 2, 3, 4, 5. 5 into 2, 10 possibilities. Now let's look at 5C3. And here too we can see that 1, 2, 3, 4, 5 into 2, 10 possibilities. So the number of possibility turns out to be the same. Of course, 3 items is 3 items, 2 items is 2 items. That difference you guys need to realize. So the proof is quite simple actually. So we'll take the RHS. So NCN minus R. That is nothing but n factorial divided by n minus of n minus r factorial divided by r factorial. Sorry, n minus r factorial. So in place of r, we are substituting n minus r, right? So this is your substitution post the formula, writing the formula and all of that. So n factorial, further simplification. So here n will get cancelled. Minus of minus is plus, r factorial into 1 by n minus r factorial. But if you look carefully, this is nothing but your NCR itself, hence proved. As simple as that. Okay, again, all of this we will be using it in higher order thinking questions, so it's better to know. Fact number 2. Again, actually, the previous one, we'll be using it in one more chapter called as binomial theorem. So they too will be using that fact. So fact number 2. NCR plus NCR minus 1 is equal to N plus 1 CR. So how does it look like? We have, say, 15C 10 plus 15C 9 apparently is equal to 16C 10. Okay, so let's have a look at the proof. So we'll start off with LHS. We have NCR plus NCR minus 1. Again, we are substituting it into the formula. So this will look like n factorial divided by n minus r factorial into r factorial. So the first term is simple, straightforward. The second one is n factorial divided by n minus of, let me use square brackets, factorial into r minus 1 factorial, right? Now this is equal to n factorial divided by n minus r factorial into r factorial plus n factorial divided by n minus r plus 1 factorial into r minus 1 factorial. So one of the ways of further simplification is we're going to expand this and we're going to expand this and take common and all of that. So in the numerator we have n factorial, that is common. So we'll not change anything over there. In the denominator, n minus r factorial will be so, while r factorial can be written as r into r minus 1 factorial, right? That's how we can take it common, plus n factorial. So this, for some people it might be confusing. Just have a look. N minus r plus 1 into n minus r factorial into r minus 1 factorial. Okay, so this is from the fact that 10 factorial is nothing but 10 into 9 factorial, right? So this is to be reduced by 1 and written as a factorial, and that's what I've done. So this is like 10 factorial. So I've written over here 10 into 9 factorial, right? I just expanded it with a single term. Okay, so please get this funda. This is where you guys can go wrong. And further, I'll take common. So in the numerator we have n factorial. In the denominator we have n minus r factorial and r minus 1 factorial into, inside the brackets we have 1 by r plus 1 by n minus r plus 1, closing the brackets. Okay, and now a bit of simplification. N factorial divided by n minus r factorial into r minus 1 factorial, and the LCM here is n minus r plus 1 into r, so it would be so, and in the denominator r into n minus r plus 1. So this will cancel each other, and in the numerator we have n into n plus 1, n factorial into n plus 1. Again, if I have 10 factorial into, or 9 factorial into 10, that would be nothing but 10 factorial, is it not? Similarly, here we have n factorial into n plus 1, so that would be n plus 1 factorial, this entire thing divided with, in the denominator, n minus r factorial into n minus r plus 1 factorial, so this will be n minus r plus 1 factorial, and r minus 1 into r, right? R minus 1 factorial into r is r factorial itself. And this, if you carefully look at it, I can rewrite this as, is it not? So let me put this inside square brackets, and this is how I can rewrite it. I'm just rewriting it, nothing else. And this is nothing but, yes, what we want, n plus 1 CR, and that is nothing but RHS. Okay, it's as simple as that. And you guys have to write everything. No option, have to write.